Dear students, in this video, we are going to learn what are lattice planes or crystal planes, how crystal planes are represented by using Miller indices, the steps involved to obtain Miller indices, and how to draw the crystal planes. First of all, I am defining what are lattice planes or crystal planes. Lattice planes or crystal planes are defined as the planes which are passing through the more number of lattice points or here more number of lattice points we have mentioned because we are defining only high dense planes. We are defining only high dense planes because those planes only reflect the X-rays. So therefore, the planes which are passing through the more number of lattice points are known as lattice planes or crystal planes. We know in the crystal, the atoms are arranged in a periodic manner. So if you locate the imaginary positions of all atoms or molecules in a crystal in the space, the resultant is known as space lattice. Now I will show the two-dimensional space lattice. So this is the two-dimensional space lattice. So the planes passing through these lattice points are the lattice planes or crystal planes. So we can define the planes like this. So these are the one set of lattice planes. We can also define lattice planes like this. These are another set of lattice planes. We can also define the planes like this. So this is the two-dimensional picture. So that's why the planes are looking like a lines. Don't confuse. So now I will show the three-dimensional view here. So these are the lattice points. So now we will define the planes passing these lattice points. So these are the one set of lattice planes, parallel planes. These are the another set of lattice planes. These are the another set of lattice planes. So from this, what we can assume, any crystal structure can be considered as a set of parallel planes. Any crystal structure can be considered as a set of parallel planes. To represent these lattice planes or crystal planes, we are using Miller indices. Miller is the name of the scientist. We are using Miller indices. What are Miller indices? Miller indices are the smallest integers, the ratio of which is same as the ratio of reciprocals of crystal plane intercepts on the crystallographic axis. Generally, we are using HKL for notating Miller indices. For suppose, if we take a lattice plane whose Miller indices are HKL and intercepts of the crystal plane on the crystallographic axis are PQR, then from the definition of Miller indices, the ratio of these Miller indices, that is H is to K is to L, is equal to the ratio of the reciprocals of the intercepts. What are the intercepts here? PQR. What is the reciprocals? 1 by P, 1 by Q, 1 by R. So the ratio of those reciprocals of the intercepts is equal to the ratio of these Miller indices. So if you want to get the Miller indices, take the intercepts and take the reciprocals and convert into smallest integers. So these are the steps we are taking to get the Miller indices of a crystal plane. So now I am going to discuss the steps involved to obtain the Miller indices. Further, let us take a crystal plane. See here, this ABC is the crystal plane. OA is the intercept of the plane on the x-axis. OB is the intercept of the plane on the y-axis. OC is the intercept of the plane on the z-axis. These intercept values we are telling as a multiples of lattice parameters among these x, y, z axis respectively. So the lattice parameter along the x-axis we named as A, along the y-axis we named as B, along the z-axis we named as C. So if you see here, it is 2 times. So it is we can name as 2A. If you see here 1, 2, 3, so it is we can take it as a 3B. If you take here 1, 2, it can be taken as a 2C. Okay, so like that we are measuring these intercepts as a multiples of these lattice parameters along the x, y, z axis. So we will take the first step, determine the intercepts of the plane along the crystallographic axis x, y, z. For example, those are PA is the OA value, PQB is the OB value, and RC is the OC value. That means the intercept on the x-axis for suppose PA. That is P times lattice parameters along the x-axis. Q times lattice parameter along the y-axis. R times lattice parameter along the y-axis. Now we will take a quantitative example here. So it is along the x-axis 1 to 2A, along the y-axis 3B, along the z-axis 3C. But we have to express these intercepts as a multiples of these lattice parameters. So express them as a multiples of unit cell dimensions along the x, y, z axis. So we can name it as P A by A. So it is P. Q B by B, that is Q, and R C by C. So we can convert P Q R. 2A by A, 2. 3B by B, 3. 2C by C. That is 2. Next step is take the reciprocals. So determine the reciprocals of these numbers. 1 by P, 1 by Q, 1 by R. That is 1 by 2, 1 by 3, 1 by 2. Next, take the LCM here. The LCM of this one is P into Q into R. The LCM of this one is 6, you know. So find the LCM. Then multiply with this LCM value. So PQR into 1 by P, that is equal to QR. PQR into 1 by Q, that is PR. PQR into 1 by R, that is PQ. So multiply this one, 6 into 1 by 2, 3, 6 into 1 by 3, 2, 6 into 1 by 2, 3. So multiply with LCM, QR, PR, PQ. That is 3, 2, 3. Then show these values in the parentheses, that means a square bracket or curved bracket. So those are the Miller indices. So like this, without any comma. Without any comma, you have shown. So these are the melons of this crystal plane 3, 2, 3. Okay, these are the steps. Now we will discuss what are the important features of these Miller indices. Important features of Miller indices are all the parallel equidistant planes have the same Miller indices. That means if you take planes parallel to each other, all these are having the same Miller indices. So that means the Miller indices not only look at a single plane, they are locating a set of equidistant planes. They are locating a set of equidistant planes. Next, if a plane parallel to any one coordinate axis has an intercept of infinity, that means if the plane parallel to any axis, what is the corresponding intercept? We have to take the corresponding intercept as infinity. Then reciprocal of infinity is 0. So that means if the plane parallel to any axis, the corresponding Miller indices is 0. If plane is parallel to any axis, the corresponding Miller index is 0. So if the Miller index in the expression is 0, for suppose we can say that plane is parallel to x-axis. If Miller index in y position is 0, we can say that plane parallel to y-axis. For suppose if you take 1, 0, 1 plane, this parallel to y-axis. If you take 0, 1, 1, this is parallel to x-axis. If you take 1, 0, 0, this plane is parallel to y and z axis. That means this plane is parallel to YZ plane. So like that you can do. And if the Miller indices of two planes have the same ratio, for suppose if you take 8, 4, 4, what is the ratio? 2:1:1. 4, 2, 2. What is the ratio? 2:1:1. That means ratio is same. Then we can say these planes are parallel to each other. And if the plane makes an intercept on the negative axis, then we have to put bar above that Miller index. So here, if you put a bar above this Miller index, then it intercept on the negative x-axis. So if you put a bar against this Miller index, above this Miller index, then we can say it intercept on the negative y-axis. If you put a bar against this Miller index along the z-axis, then it is intercept on the negative z-axis. Okay. So these are the important features of Miller indices. Now we will practice how to draw the crystal plane. So for this crystal plane, I am following one notation. It is not universal, but I am following this one. You also follow this notation for easy representation of crystal planes. If the axis moving towards positive, towards rightward in horizontal direction, that we can take as a positive x. If the axis is moving leftward, we can take it as a negative x-axis. So if the axis is moving towards rightward, we can take positive. If it is leftward, we can take negative x-axis. If axis moving upward is positive y, moving downward is negative y. If the axis is moving outward, it is positive z. If it is moving inward, negative z. This notation is better to follow. Okay. So if you want to draw any crystal plane, the first step is we have to take a cube. After taking a cube, we have to take any one corner as the origin. How to choose which corner as the origin, that depends on the Miller indices given there. Okay. So here, if you take a cube here, if you take origin here, from here axes are taken along the edges of this unit cell. Then here it is moving rightward, so positive x. It is moving upward, positive y. It is moving outward, positive z. For suppose if you take origin is here, from here it is moving leftward, so negative x. Here moving downward, negative y. It is moving outward, positive z. So in this way, so each corner we are getting the different combinations of these axes. Those are x, y, z, x bar, y, z, x, y bar, z, x, y, z bar. Like that, 8 different combinations we are getting. So 8 corners. So in this way, what corner we have to choose as origin, that depends on the Miller indices given there. If all are positive, then this is the origin. If all are negative, this is the origin. Why? This is leftward, negative x, downward, negative y, inward, negative z. So here all are positive, here all are negative. And here if you take the positive x, negative y, negative z. So like that, what millions are they have given, based on that one, we have to choose the any one corner as the origin. After that, we have to define axis. After defining the axis, we can draw the crystal plane. That is the method we have to follow. Here, I will show some planes here. So this one, this plane, if you take, it is parallel to y and z axis. So the Miller index correspond to y is 0. Miller index correspond to z is also 0. And it makes a intercept, and this intercept is a. So a by a 1, so reciprocal of 1 is 1. So this plane is 1, 0, 0. So this plane is 1, 0. And if you take this plane here, is parallel to y-axis. So the Miller index correspond to y-axis 0, and x-intercept is A, and z-intercept is C. So A by A 1, C by C 1. So reciprocal of 1 is 1, reciprocal 1 is 1, and here index is 0. So 1, 0, 1. This plane is 1, 0, 1. And if you take this one, A, B, C, so divide with A, B, C, then 1, 1, 1. Reciprocal of 1, 1, 1 is 1, 1, 1. So this plane is 1, 1. Like that, if you take this plane here, the x-intercept is A and parallel to Y, so that Miller index is 0, and the z-intercept is C by 2. So here A by A 1, here C by 2 by C 1 by 2, and reciprocal of 1 here is 1, here reciprocal of 1 by 2 is 2. So here 1, it is 0, it is 2. So this plane is 1, 0. And if you take this one, so x-intercept is A by 2, and z-intercept is C by 2, and parallel to Y. So A by 2 by A, 1 by 2, C by 2 by C, 1 by 2. Here it is intercept is infinity because parallel. So reciprocal is 2, 0, 2. So this plane is 2, 0. So this one, x-intercept is A by 2, y-intercept is 1, z-intercept is 1. That means A by 2, B, C. So A by 2 by A, 1 by 2. B by B 1, C by C 1, 1 by 2, 1, 1. Reciprocal is 2, 1, 1. For suppose they ask you to draw this plane. Generally, we will not give any plane, and we will not ask the Miller indices. We will give the Miller indices. We will ask you to draw the crystal plane. So we will give Miller indices. We will ask you to draw the crystal plane. So now here Miller indices are given 0, 1, 1 bar. We ask you to draw the crystal plane. So here, if you 0 is there, that we can take as a positive. So x is positive and y is also positive, but z is a negative. So if any plane they ask you to draw, the first step is you have to take a cube. Then you have to choose the origin. Here positive x, positive y, and negative z. Positive x means rightward. So out of these 8 corners, from these 4 corners only the axes are moving rightward. So definitely out of these 4, any one will be the origin. Next, go to the y. Y is also positive. Y positive means the axis has to move upward. So out of these 4, from these 2 points, the rays are moving upward. So that's why you can choose any one of these 2. Then any one out of these 2, how we can choose? By going to the third one, z-axis. Z-axis, it is negative. So negative z-axis means moving inward. So you have to choose this one as the origin. So okay, if you choose this one as the origin, then from here it is moving inward, the negative z, and here it is moving rightward, positive x, and moving upward, positive y. Then here the x-intercept is, here it is Miller index is 0, so it is parallel to x-axis. So leave like that. Y-intercept is reciprocal of 1, 1. So the y-intercept is 1. Z-intercept is reciprocal of 1, 1. It is on the negative z-axis. Here it is. So these 2 points take first, and from this the plane is parallel to x-axis. So from these points you draw lines parallel to x-axis. Parallel to x-axis. Then these 2 points you join, and these 2 points you join. Then highlight this one, and this plane is the 0, 1, 1 bar plane. This plane is the 0, 1 bar. Now 1 bar, 1 bar, 1 bar. All are negative. Negative x means moving leftward. Negative y means moving downward. Negative z means moving inward. So in this is the origin. From here, it is moving inward negative z, and moving leftward negative x, and moving downward negative y. So the x-intercept is reciprocal of 1, 1, and y-intercept is reciprocal of 1, 1 on the negative axis, and z-intercept is reciprocal of 1, 1 here, and join these 3 points. So this is the plane. I will show some more planes here. 2 bar 0, 1. That is negative x, positive y, and negative z. Okay. So which one we have to choose? Negative x means leftward. So that means out of these 4, any one you have to choose. Okay. Next, positive y. Positive y means upward. That means out of these 2, any one you have to choose. Next, negative z means inward. So this one. So this is the origin. So this one you have to choose as origin. From here, leftward negative x, upward positive y, inward negative z. And here x-intercept is reciprocal up to half. So x-intercept is here somewhere at half, and parallel to y. And next z-intercept is reciprocal of 1 endpoint only. So from this intercept point, draw a line parallel to y-axis. This is the y-axis. So draw the line parallel to y-axis here and here. And join these 2 points and join these 2 points. So this is the 2, 0, 1 plane. So I will show one more plane here. 1 bar, 2 bar, 2. So that is negative x, negative y, and positive z. So first to draw the cube. Negative x means here you have to come. Negative y means here you have to take because downward. And positive z means this is. So this is the origin. So negative x, negative y, positive z. Then x-intercept is reciprocal of 1, 1. Here that x-intercept. And y-intercept is reciprocal of 2, 1 by 2. That means here somewhere at half. And z-intercept is reciprocal of 2. That is here at half. So join these 3 points. So join these 3 points here. And highlight. So this is the like that. I will show one more plane here. Negative x, positive y, positive z. It is parallel to y and z axis. Okay. So here negative x means out of these 4 anyone. Positive y means here out of these 2, and positive z means this is. So this is the origin. So negative x, positive y, and positive z. On the x-axis, the intercept is reciprocal of 2, that is half. And from this, it is parallel to y-axis. So you parallel to y-axis, and parallel to z-axis, and parallel to z-axis. So join like this and complete this one. So this is the 2 bar 0, 0 plane. Okay. Still you have any doubt? You can approach me anytime. We are in the campus only. Anytime you can come to us. We are available during the college hours from morning 8:45 to 4:30. And not only this topic, any topic related to engineering physics, you have any doubt, you can come to the college. We will discuss here. And not only the theory, in lab also you have any doubt, you can come to the college. We can perform the experiments. You can practice the experiments here. So thank you all. Utilize our services by coming to the college. You can discuss any doubts are there, or you can perform the experiments also. So thank you once again. Thank you all. And this topic, what I have discussed in this video, is very important. Based on this topic, definitely you will get one question in the end examination. So practice. carefully. Thank you all. Thank you.